Good morning, everybody. Today, my topic is metallurgy of aluminium. Myself is Manmohan Krishnan, lecturer in chemistry, Government Polytechnic College, GTB Gad. So, let's start metallurgy. So, the brief introduction about the metallurgical operations is so, first of all, the ore is purified. So, first step is purification, another is oxidation, then reduction, and the last step is refining. So, the metallurgical operations involves this step. So, first of all, the ore is purified, and then oxidation and reduction takes place, and then at last refining is done to get pure metal. So, today we are particular about the metallurgy of aluminium. So, metallurgy of aluminium. Atomic number of aluminium is 13 and atomic weight is 27. So, aluminium is not found in native state, but it is found in combined state. But is available in compound state. So, the different compounds of aluminiums in which we get aluminium. So, these are called ores of aluminium. So, the different ores of aluminium are, so at first of all, the oxide ore, bauxite, so Al2O3 2H2. So, the ore of aluminium is, main ore of aluminium is bauxite, and then diaspore, and third one is corundum, Al2O3. So, the oxide ores of aluminium are bauxite, diaspore, and corundum. Next ore of aluminium is feldspar. So, feldspar is this is the silicate ore, silicates. Another ore of aluminium is alunite. So, the alunite ore of aluminum is potassium sulphate and aluminum sulphate aluminum hydroxide. The sulphate ore of aluminum is alunite. So, the different ores of aluminum are bauxite, diaspore, corundum, feldspar and alunite. Next is cryolite. Another ore of aluminum is cryolite, that is Na3Alf6. So, these are ores of aluminum. Next is metallurgical operations. The ore from which aluminum is generally extracted is, that is, by bauxite. The most important ore is bauxite, from which aluminum is extracted. So, first of all, the purification of bauxite is done. So, the general methods of purification, general method of metallurgy is purification of ore and then electrolysis of alumina, and the third step is refining. So, these are the process of metallurgy, that is, at first of all purification is done and then electrolysis of alumina is done and then at last refining is done. So, purification of aluminum or bauxite. So, bauxite are of two types, red bauxite and a white bauxite. So, there are two types of bauxites, so red bauxite and white bauxite. If the impurity is present in bauxite is ferric oxide, then it is called red bauxite. If more of ferric oxide is available, then it is red bauxite and the color of ore is a reddish color. And if the more impurity of a silicon dioxide is present, then it is called a white bauxite. So, the different method available for purifications of these bauxites are: for red bauxite there is a beige process, and for white bauxite there is Serpek process. Okay. For red bauxite there is beige process and for white bauxite there is a Serpek process. Hall process Hall's process remove both the impurities of bauxite ore, that is, Hall's process remove red bauxite as well impurities of red bauxite as well as white bauxite. So, at first of all in purification we discuss about beige process. Bayes process. So in Bayes process, the grounded ore is treated with caustic soda the formation of sodium meta-aluminate. The reaction is written as NaOH and the reaction is the ferric oxide is converted into ferrous oxide and aluminium oxide, that is grounded ore bauxite, is converted into sodium meta-aluminate. Sodium meta-aluminate on hydrolysis becomes aluminium hydroxide and sodium hydroxide. So there is a formation of precipitates. So on reacting bauxite with sodium hydroxide, this formation of sodium meta-aluminate, this is filtered and the filtrate contains sodium meta-aluminate, and on hydrolysis it becomes aluminum hydroxide, which on ignition washed. The precipitates are filtered and washed, and on ignition gives pure alumina. This is pure alumina. So in Bayes process, aluminium oxide, that is roasted ore, grounded ore, is mixed with sodium caustic soda and the formation of sodium meta-aluminate, which is in filtrate. Sodium meta-aluminate on hydrolysis gives aluminum hydroxide, which are the precipitates. So the precipitates on ignition give rise to pure alumina. So this is the Bayes process. Another process is Hall's process. Hall's process. So the Hall's process is, so in Hall's process, the powdered ore is fused with sodium carbonate. Is fused with sodium carbonate. The fused mass is extracted with water, aluminum oxide being amphoteric dissolved to form sodium meta-aluminate, while the impurities like oxides of iron and silicon remain insoluble. aluminium oxide this is formation of sodium meta-aluminate sodium meta-aluminate plus water plus carbon dioxide so the meta-aluminate formed the filtrate is sodium meta-aluminate and the remaining parts on filter paper that is impurities of iron oxide and silicon dioxide. These on hydrolysis give rise to aluminium hydroxide which on the precipitates filtered, washed and ignited to give pure alumina. The precipitates are filtered, washed and ignited to give pure alumina. And then is next is the purification of white bauxite. Purification of white bauxite. So purification of white bauxite, for purification of white bauxite there is a SAPAC process. SAPAC process. So in this process the powdered ore is mixed with coke and heated to coke and heated to 2073 Kelvin in nitrogen atmosphere, and the reactions is Al2O3 plus carbon plus nitrogen, and there is a formation of aluminum nitride plus carbon dioxide. Okay. So there is a formation of nitride. The powdered ore is mixed with coke and heated to 2073 Kelvin in an atmosphere of nitrogen. Alumina combines with nitrogen to form aluminum nitride, while silica is reduced to silicon, which volatilizes off at this temperature. The silicon dioxide if present is reduced to silicon, which volatilizes off plus carbon. So the silica if present it volatilizes off. So, the silica if present it volatilizes off at this temperature. So, in Serpek process the powdered ore is mixed with coke and heated to 2073 Kelvin. The alumina, that is ore mixed with coke in nitrogen atmosphere, there is formation of aluminum nitride and carbon dioxide. Volatilizes off, and the silicon, that is due to which the bauxite is white, that is volatilizes off at this temperature. The aluminum nitride is hydrolyzed and the formation of aluminum hydroxide and ammonia. The precipitates of aluminum hydroxide, these are again filtered, washed and ignited to give pure alumina. So, they give pure alumina. So, again pure alumina is formed. So, this was purification of red and white bauxite. The different processes were beige process, Hall process and Serpek process. And the second is next step is electrolysis of fused alumina. So, the fused alumina formed in Serpek process, or either it may form in beige process or Hall process. It is again forwarded for electrolysis. So, next is electrolysis of pure alumina. So, in electrolysis process, so pure alumina cryolite and fluorspar they are mixed in 1:3:1 ratio. In electrolysis process, pure alumina, cryolite and fluorspar is added in 1:3:1 ratio, that is pure alumina 1 part and cryolite 3 part and the fluorspar is 1 part. Cryolite is added, it is added to increase the conductivity. So, electrical conductivity and decrease melting point from to increase conductivity and to decrease melting point from 2273 to 1173. Okay, 2273 to 1173 Kelvin. So, cryolite is added to increase conductivity and to decrease melting point from 2273 to 1173, and the calcium fluoride, that is fluorspar, is added to increase the fluidity of mass, so that increase the fluidity of mass, so that the liberated aluminum may sink at the bottom of the cell. So, the electrolysis process include so there is a iron tank in which carbon lining act as cathode, so this is cathode, carbon as cathode, and anode is carbon rods, these are made anode. So, carbon rods are anode. Anode, carbon as anode. So, carbon as anode and carbon lining as cathode, and the electrolytes this is tap hole for aluminium. To avoid oxidation of electrolyte, charcoal powder is sprinkled over it. Charcoal powder to avoid oxidation of electrolyte. Okay. So, the different reactions at cathode and anode involves. So, aluminum oxide, that is broken into aluminum plus oxygen, aluminum plus oxygen. At cathode, aluminum take up electrons. So, 4 aluminum here are shown. Aluminum take 12 electrons and form aluminum. At anode, oxygen give electrons